Hi calculus friends! I'm here to do some implicit problems for you today to kind of follow up on what we were doing in class on Wednesday after we had reviewed for the quiz. So the first problem we're going to do here, this is from another packet, but you can just add this onto your notes. We have a standard type of expression that we would be using implicit differentiation on, 2x squared minus 4y cubed equals 4y. And we're being asked to find dy dx at 2, 1. Okay. So what you have to remember is that we have to find the expression first and then substitute in x equals 2 and y equals 1. Okay, so writing the expression for the derivative first and then doing the substitution, just like anytime we're being asked to find the value for a derivative. We need the derivative function first and then the substitution happens. All right, so let me grab my, I wonder where my screen capture toolbar went. Hello, screen capture toolbar, where are you? Oh, there it is. It's under my recording thing. All right, so let me grab this expression, send it to a new page. So here it is. And I'm going to write the derivative, or I'm going to get my dy dx. And it's kind of weird because you just kind of start. So 4x equals, not equals, sorry. 4x, try that again. 4x minus 12y squared dy dx equals 4 dy dx. We're taking the derivative implicitly with respect to x, so x is normal and y is treated as a function of x, and so every time we take the derivative of a y, we have the chain of the dy dx added on. Okay, so here's what I'm going to do. I'm going to just move my 12y squared dy dx over to the right side. Just means I have a little less negatives. So 4x equals dy dx. And, you know, this might be, if you might pause this and then do it yourself and then see what the final answer looks like. It's kind of up to you how you use the video. So this would have been a good review question, though. It would have been good just to kind of try it without me and see what you remembered. And so here's dy dx, 4x over 4 plus 12y squared. And if I go back and remember, 2, 1 is our point. So at 2, 1, that will be 4 times 2 over 4 times 12 times 1 squared, plus 12 times 1 squared. So 8 over 16, or a half. When we're finding the value of a derivative that we've taken implicitly, we will typically need an x and a y because our derivative will probably be an x and a y. And sometimes that's a trick or something that we run into, is that we're being asked to find dy dx, but maybe we're not given both x and y. And it might be something where we have to go back to the original function to find one or the other. We'll look at something like that. Okay, so the reason I wanted to start with this problem is because there's a follow-up problem to this problem. Oops, I'll blink there, but we're good. The follow-up problem to this problem is to find now the second derivative of the exact same expression. And so to find the second derivative, we would, and make sure we make a little note here, this is asking for the second derivative. We would need dy dx first. Okay. And so let's go back to what we got for our dy dx in symbolic form. 4x over 4 plus 12y squared. Oops. Okay, here we go. 4x over 4 plus 12y squared. All right. Now to take the second derivative, dy2 over, or actually d2y, I always mess up that notation, sorry, go. Second derivative, I'm going to take the derivative of this, I'm going to use quotient rule, and I'm still going to be attacking this implicitly. So watch what's going to happen. All right. I'll take my denominator times the derivative of my numerator minus my numerator times the derivative of my denominator. 24y dy dx. Because anytime I take the derivative of the y, I will still need a dy dx. All divided by the denominator quantity squared. Now, this is a pretty ugly expression. Luckily, we're not being asked to rewrite this in any kind of algebraic form. We're asked to find the value of this at 2, 1. Now, I want you to notice I don't have to do anything else to finish my second derivative. This expression is my second derivative. There's no like getting anything by itself, like when we do the first derivative implicitly. A second derivative implicitly in a way is easy in that there's no rearranging. It's just whatever the derivative is over here, that's your second derivative. But notice that it's got a first derivative in it. So when I go plugging in 1 for y and 2 for x, x is 2, y was 1, you're going to have to look back at what dy dx is. Dy dx was 1/2. And so that's what's going to go for the y will be the 1, the x will be the 2, we'll be plugging a 1/2 right here. Minus 8 times 24 times a half. That's over 6. Yeah, okay, I remember this answer. And when you get the final answer to this problem, the final answer will be -1/8. I'm going to let you work through that. I will write out the steps, but I'm not going to do them on the video. But I'll have them written in the note paper so that you can look at them if you can't get to the -1/8 by yourself. Okay. We don't often do a second derivative implicitly, but if we do, it will be, you take your first derivative first, get dy dx equals, and then take the derivative of that. Oftentimes when we've been asked to do this, as I've seen this in the AP exam, we have started with a dy dx. So, you know, they might say, okay, dy dx equals 3 minus x over 2y. Find d2y dx2. So denominator, derivative of numerator minus numerator, derivative of denominator over denominator squared. And then if this wasn't a find the value, we would actually have to put this expression in here. I don't know that we have a practice place for this, but I wanted to make sure that you had access to this and went through it, and we will make sure we pull this up again and talk about this at another point. Okay, so second derivatives using implicit. Make sure that's something in your notes.